Hello everyone and welcome back to the channel. Today we will be solving starters 142 number hunt where you are given a positive integer x. You need to find the smallest positive integer y which satisfies all of the following conditions. First of all, y should not be prime. Y should not be a perfect square and no factor of y other than 1 is less than x. Now the constraints of x go up to 10 raised to 9. So you cannot brute force in all possible values above x. That will give a very high time complexity answer. You need something that is more optimal. Okay, so first of all, it should not be prime and should not be a perfect square. Now, when is a number not prime? A number is not prime when it can be when it can be shown as the multiplication of two or more numbers more than 1. So if I am saying my possible answer is Z, I should be able to represent Z in the product of two numbers x and y. If this is possible, that means Z is not prime, which satisfies my first condition. Now, second condition, it should not be square. If I am able to represent x as the product of two numbers x and y, and x is not equal to y, then that means this equation is also successful. So now the question arises that I just need to find a number z which is the product of two numbers which is more than 1. Okay, now there is one more condition. The condition is that the factors of z should not be less than x. It says that no factor of your final answer other than 1 is less than x. Okay, let's remove this x and y because it interferes with the question. Let's say our number is a is equals to b into c. If you find out the factors of a, it should be 1 and all of the other factors should be more than or equal to x. None of them should be less than x. Now, my thinking says that we will always make the answer of a using two prime numbers more than equals to x. Why is this? This is because let's say x is something 37 and you multiply and you use 37 into 38. Since you are needing the smallest possible value of a, you will of course choose the lesser numbers to multiply. But now 38 when further uh, composed into factors gives us 2 and 19, which will make our condition false that I need all of the factors should be more than or equal to x. But if I use two prime numbers like 37 and 41, if I choose two prime numbers, then these two prime numbers are not at all decomposable into any more factors, which is why our this condition becomes true. So first of all, you need to multiply it by two prime numbers. If you use a composite number, it will further decompose and you may get a factor that is less than x. So we will choose two prime numbers. We will choose two different prime numbers the so the number is not a square. So now the question arises that we just need to find two prime numbers greater than or equal to x and multiply them off because you need the smallest positive integer y. smallest. So you will choose the smallest two prime numbers available. Okay. Now the samples 1, 2 and 3. For 1, our two closest prime numbers are 2 and 3. The answer is 6. Okay. For 2, the answer is still 2 into 3. For 3, the answer will be 3 into 5, which is 15. Okay. So now here is the code. I need to find two prime numbers, different prime numbers, greater than equal to x. So my find function finds the next prime number that is strictly greater to value. Okay, so now if x is not prime, then I find the next prime of x, and then I simply multiply the answer of x and the next prime which I find. Okay, long story short, find two different prime numbers greater than equal to x and print the product of that. That is your final answer. Okay, so thank you guys for watching. Make sure to like and subscribe the video to never miss another tutorial.